Today's lesson is about parallelograms. We're going to learn about the properties of parallelograms. Now, I know most of you have seen parallelograms before, but we're just going to review some of these properties. Some are familiar to you, some may not be, all right? And we're going to solve problems in this section dealing with parallelograms. Now, let's start with some obvious things. One of the first properties of parallelograms is that you have, first of all, it's a four-sided shape, it's a quadrilateral, and also there's these properties we're about to talk about. But one main property that you probably should know about is the fact that if I have these four sides, then its opposite sides are equal. So I'm going to make a mark right here at PQ. I'm making a mark at RS, good initials. Then I'm going to take QR and put two things there, because it's obviously not as the length of PQ and RS, good initials, and PS. So this is something that you should already remember. Just remember that PQ and RS, good initials, are congruent, and PS and QR are congruent. So all you have to remember for this is that opposite sides are congruent. But you say, yeah, but that's a rectangle, right? Well, we gotta go back to the word parallelogram. Not only are these pairs of sides congruent, but they're also parallel. And remember, we used to mark do you remember how we used to mark parallel sides? Anybody remember? Yes. You put the little arrow and shade it in. And you have to do that on both sides to show that those two sides are indeed parallel. Now, since I made one mark here on these two segments, then I need to make two marks, just like I did when I was showing congruence on this other pair of sides. So I'm going to put that right there and right there. So that's what you have to remember, that these two sides are, each pair of sides here are both parallel and congruent. So I'm also going to mark here that PQ is parallel, remember the two lines being parallel, and RS, good initials, those line segments are parallel and congruent, and then also PS and QR are parallel. So opposites are congruent, and I really should not have said opposites, I'm sorry about that. I should have said opposite sides are congruent, and they are parallel. Okay? That's one of the main things that makes a shape a parallelogram. Now, let's talk about what's inside that parallelogram. So I've drawn a similar parallelogram in this picture, and we're going to talk about what's inside of it in these next couple moments here. What you have to remember here is that if I have angle P, which is right here, and angle R, which is right here, we can say that those two angles are congruent. So what I'm going to do is I'm going to mark that the same way that I mark this. Okay? Now you know how to draw off scale. I always tell you how to draw off scale, but trust me, they are congruent. All right? Now, if you think P and R are congruent, what do you think about the other ones? Yeah, you got it. Q and S are also congruent. Now, since we don't know that they're equal, that's why I went ahead and made two marks on both Q and S. So, here's what you have to remember. What you have to remember is that the opposite angles, if this angle is right here and this angle is right here, they are opposites of each other, and therefore they are congruent. So we make a mark right here and say that opposite angles inside a parallelogram are congruent. All right? Which means, in this picture, that angle P is congruent to angle R, and angle Q is congruent to angle S. Okay? So those opposite angles inside a parallelogram are congruent. Okay? Now, you got that down? Because what I'm going to do is I'm just going to erase this mark, this thing right here, this piece right here, and continue to talk about the angles. There's something else we can talk about with these angles. Okay? You got that down? Good. Now, we've already marked that these angles are congruent based on whatever it is we've talked about. We said that they are congruent opposite angles. But what you also remember from perhaps when we talked about, what was it? When we started talking about parallel lines in general, we learned about what's something called consecutive interior angles. That was the only pairs of angles besides just normal angles, whatever, that were also supplementary. And that's kind of happening here. Remember, going back to this picture, we've already marked that this and this are parallel. This and this are parallel. So what that means is that the angles that are inside parallel lines, consecutive interior, are supplementary. So in this picture right here, if we know that this is parallel to that, and this is parallel to this, then we can state the following. We can state that this angle plus this angle equals 180 degrees. So in this case, M, the measure of angle P, plus the measure of angle Q equals 180 degrees. All right? Are there other statements we can write? Sure. We can say that P and S are also supplementary. They add up to 180 degrees. So the measure of angle P plus the measure of angle S equals 180 degrees. All right? Can you name the other two facts based on something like this? Okay. One is that angle Q plus angle R equals 180 degrees. And the last one? Yes. Angle R plus angle S equals 180 degrees. So in other words, the angles that are consecutive, which are right here in order, going from here to here, they're right next to each other. They're not adjacent, they're just consecutive. So just remember that consecutive angles inside a parallelogram are supplementary. Okay? So look at that. We've already learned 3 facts about parallelograms. So now it's probably time that we put these things to the test. So we're going to do some algebra with some problems here. Okay?